Everybody, welcome back to chemistry. So if I can increase the slide, it says aqueous solutions of silver nitrate and sodium phosphate are mixed together, forming solid silver phosphate and aqueous sodium nitrate. Write the balanced chemical equation for the reaction. Phases are optional. Okay, if I can lower the slide. Okay, so we have to take those sentences and write out a word equation. And then from the word equation, what we'll have to do is convert those words for compounds into formulas. And then we'll have to balance that particular formula equation. So let's go ahead and write those compounds out to get a nice word equation. And so it says aqueous solutions of silver nitrate and sodium phosphate are mixed together. So the reactants are silver nitrate and sodium phosphate. So let me write that here. So we have silver nitrate and sodium phosphate. Okay, so those are the reactants, so that'll be on the left side of the arrow. Okay, so the next thing you need to do is write out the products, and they tell you that you're going to form solid silver phosphate and aqueous sodium nitrate. So it's going to be silver phosphate is one of the products plus sodium nitrate. Okay. So they, in the end, want a balanced chemical equation for this. So now, maybe the trickiest part is for each of these compounds, you have to write out a correct chemical formula. So one thing that I hope you can be able to do is recognize both the compounds and the reactants and both the compounds and the products are ionic compounds. And so if you're trying to work out a formula for an ionic compound, you have to remember what the charges of the ions comprising that compound are. So let me start out with silver nitrate here. And so you'll just have to remember that silver has a single positive charge. You'll have to remember that nitrate is a polyatomic ion, so I'm hoping you remember its formula is NO3 minus. Now, what you can do is you can write out a correct chemical formula for silver nitrate. And so there are a lot of ways you can do this. But you can sort of do it if you want by crisscross. So we have AgNO3. And so here with the nitrate, we have 1 minus charge, and so we bring the 1 to silver, so the silver will be 1. With silver, we have 1 positive charge, we bring the 1 to the nitrate, so we have 1 nitrate. So this is the correct formula for silver nitrate. Okay. Sodium phosphate is a different compound. It's sodium is plus, and then phosphate is PO4 3 minus. And so by crisscross, let's figure out what this is going to be. So you can see that phosphate here has a 3 minus charge, and so we have to take the 3 from phosphate, ignore the negative sign, take the 3 and give it to sodium. So it's Na3. And then sodium, it has a single positive charge, so we take the 1 from sodium and give it to phosphate. And so we only have 1 phosphate. If we only have 1 phosphate, then we don't need to write parentheses around it. That's good as it is. Okay. Now, silver phosphate, so silver is Ag plus, phosphate is PO4 3 minus. And so kind of the same deal. You can do crisscross to figure out the formulas here, and hoping you can work out that the correct formula for silver phosphate is Ag3PO4. And then same thing with sodium nitrate, it's Na plus, nitrate NO3 minus, and so this is NaNO3. Okay. I'm going to leave out state symbols for these compounds, and I don't think you need to put them in to answer the question. All right. But they do want this equation balanced. And so what you have to do is for each of the elements, you have to check there are as many elements of that particular kind on the left side of the arrow as there are on the right side of the arrow. Now we have a bit of a complication. We have polyatomic ions, and maybe one of the things you learn is that you can most of the time balance whole polyatomic ions as long as the elements within the polyatomic ion are not really separated when you go over to the other side of the equation. So let's go ahead and balance polyatomic ions first. That may be the easiest thing to do. So here with silver nitrate, you can see that the compound has 1 nitrogen and 3 oxygens, but really there is just 1 nitrate here. And so we can check the other side of the equation and see if there's one nitrate, and there is. So it looks like nitrates for now are balanced, okay. Let's check phosphates. So in sodium phosphate, we have one phosphate here on the left, and we have one phosphate here on the right, so it looks like phosphates are balanced, okay. So what we want to do is now balance, for example, sodiums. Looks like I'm going to need a 3 here, because now we have 3 sodiums here and 3 sodiums there. And then we have silvers, we have a 3 there, so we need a 3 here. So when we balance the silvers, for example, and the sodiums, let's check to see if the nitrates and phosphates are still in balance. And so let me check nitrates again. I'm kind of hoping you can see now that even though that this one formula has one nitrate, you have a coefficient of 3, so there are a total of 3 nitrates you have to sort of contend with on the left side. And on the right side, you also have 3 nitrates, so they're balanced. Let's check sodiums. Sodiums, again, 3 on the left, 3 on the right. Silvers, 3 on the left, 3 on the right. Phosphates, 1 phosphate on the left, 1 phosphate on the right. So this should be a balanced equation. Okay, thank you for listening to that. We'll see you next time.